to GLOBEBUSTERs.
We accept the reality of the world with which we're presented. It's as simple as that.
All right, hello and welcome to GLOBEBUSTERS Season 13, Episode 10. Today I'm joined by Shane St. Pierre and Zack, good times for all, longtime member of GLOBEBUSTERS, holding it down. I'd like to give a special thanks to Bob, who created this platform. It's a big shout out to Cami, who is continuing the platform. And if you want to support Cami and Bob's legacy, you are welcome to do the YouTube, what do they call this? YouTube Super Chats, sorry. YouTube Super Chats. You are welcome to do YouTube Super Chats. Those go directly to Cami. Please support her and help support Bob's legacy. And then in addition to that, we are going to be going over a presentation following inertial forces, where they come from. Or inertial forces and where to find them, rather. So quick note, I am on cam on the stream, but on the Discord, I won't with you gentlemen in spirit. On here, I'm having some
loving the hair,
issues. Man. Thank you, sir.
Whatever happened to 2 OBS sessions? Is that beyond?
I can't get my virtual cam working. It's a virtual cam issue right now. It's a Shane. Are you gonna make me say it out loud? I'm having a Linux issue, bro.
I knew what it was.
Are you happy?
Because Windows people can just do that, right? I'm just saying. That's all I'm saying.
Does it feel better now? Does it? Okay. Now that we're all on the same page.
It was
all right.
Yep.
Good.
Have you guys seen the new Hibbler, the Kovacs 19 documentary he put together? I think it was the best work he's ever done, in my opinion.
Nice.
Damn,
yeah.
I'll have to go watch that.
Yeah, it was really just a lot of information, and it wasn't like people like us talking about it so much. It was all like mainstream media saying one thing and then showing 3 years later what they were saying. It was so well done, I thought. Best work he's done.
Nice.
Way to go.
The old bait and switch, they get us every time.
Mm-hmm.
All right. Well, let me screen share here. Oh, so we actually have a little double feature here tonight. So the presentation isn't going to be very long, so we're going to get through that probably at about 45 minutes or so. And then we're going to go over Mana Stone's new video, and we're going to watch, but we're going to start with Taboo Conspiracy's video, which gives a nice preface to Stone's video, and also Taboo's, the content that Taboo added to it. So we're going to watch those two, which are some new and fantastic flat Earth evidences being put forward. Get into those.
What's that? A new proof every week, you say? Well,
dude, every week we're drawing a new triangle in the sky to show that the Earth's flat. I don't know. I just work here, bro. I just read off the teleprompter. All right, here we go. Let me screen share here. We'll get into my Prezi. Here we go. All right, Shane, brace yourself. This is going to be one of the most graphically intense presentations I've ever done. Because if you think that was just a thumbnail, bro, you're sadly mistaken.
Whoa, look at that. Whoa.
Dude.
Oh my.
Now, hold on. You think it's done?
It up a notch around
wait. It's just going to loop, bro. It goes on. It doesn't stop. So.
Wow.
All right. So welcome to GLOBEBUSTERS, inertial forces and where to find them. This will be a continuation of the presentation done a couple of weeks ago on inertial reference frames and where to find them, and how they're defined by classical physics and mainstream physics. And then we took, being the relativistic paradigm, and then we took a look at some dynamic analysis and found that only with respect to the lab frame can the conservation laws, can kinetic energy be converted into potential energy with the correct amounts with respect to the lab frame. Those are the only places that those hold true, and yet we're told that all inertial frames are equally valid, but we learned that they weren't valid. So now we're going to look at another aspect of inertial frames. This is going to be inertial forces. Well, that'll be non-inertial frames. So when you're in a non-inertial frame, you'll be experiencing a force. They call these inertial forces. Some people, you may have heard of them: centripetal, centrifugal, Coriolis, and Euler. These are all the things that we're going to be covering, the history of those and where they apply and what they do. So we'll go over some evidences that are put forward for the globe, because and for how gravity, because they say that the equivalence of gravity is the centripetal, so they make an equivalence there. So we're going to look at some instances where they've tried to extend measurements on the ground to their cosmological belief and see if anything holds true. All right, so to give us a little recap here, we're going to look at the mass force equivalence, which we already touched on last week or 2 weeks ago. And then we're going to look at Newton's definition of force, which is F equals ma. So there's going to be a proportionality there between the mass and the acceleration. When we look at these, when we continue to read through some of these equations, you're going to see that some of them are bolded, some of them are italicized, etc. So those are vector notations. So I'll point those out as we kind of go through that. Those are important for learning how to read mathematics when you're, most commonly people will write things in such a way that, they can just write a single variable and it will say three things rather than writing three separate things. You know what I'm saying? So that's an important distinction to recognize. So M here is going to be the proportionality constant, because force and mass are going to share a relationship here in Newtonian mechanics. So they say that mass, inherent property of attracting something through just by virtue of its existence. They don't really have a mechanism, but that's how it's described to us. So it causes an acceleration. So there's a proportionality there. And then a time derivative of velocity will help us predict inertial forces. So we touched on 2 weeks ago how you can take a time derivative of the change in velocity between two measurements and determine whether or not there's an acceleration, because if there's a change in time, that means that there's a difference in the acceleration between the two frames isn't constant. So we're looking at an acceleration. So this will be important for how we look at analysis. All right, a quick note on vectors and scalars. So when I talked about the notations earlier for bolds, whatnot, well, mass is supposed to be a force, right? But it doesn't have a direction. It doesn't have a vector. So they just call it a scalar. So it just has a magnitude, has a number value, but it doesn't have a vector. So when we do vectors, that'll be a magnitude and a direction. So it'll be, the number, like how fast it is and what direction it's going. Whereas the scalars are just all right, inertial frames and where to find them. We're going to give some examples now of where these forces would apply, given an example of we're going to pick up a box and we're going to hold it at arm's length, and then we're going to rotate with it, and we're going to describe several forces that'll be are going to be described by that. So starting out with picking up a box, you're going to feel the mass of it. You're going to feel the weight just holding it out in your arms. It's going to be heavy, and you're going to feel that force, right? You're going to feel the weight of that object. Force. Now, when you start to spin, when you're holding that object, you're going to feel that object pulling out, extending you out, extending your arms out. That's going to be the centrifugal force. And at the same time, there's going to be tension in your arms pulling you back, pulling the box back as you spin. That's going to be the centripetal force. Okay. And of course, no force is complete without Tony Coriolis force, right?
Totally Coriolis force, of course. There he is.
And Tony Coriolis says, tune in to GLOBEBUSTERS every Sunday at 3 p.m., 12 p.m. Pacific. That's a pretty awesome message from our boy. That is very impactful for us.
I appreciate the citation, notation, and the attention to detail by him citing himself on the bottom.
Tony Coriolis as himself. So the Coriolis effect, they tell us, is that, to give an example here, if you were on a merry-go-round and we were holding that box out in front of us and we were trying to walk in a straight line, the Coriolis force would be the force that fights us to deviate from that straight line, rather than one that's pulling us, straight out like the centripetal or centrifugal would in relation to the centrifugal. This will be a force that is perpendicular to the plane of rotation. So what that means is, for example, on a globe, if you had a sniper rifle and you were shooting if you were at the equator, you were shooting to the north, there would be a westward deflection. If you were shooting to the south, there would be a westward deflection. If you were shooting to the north, there would be an eastward direction deflection, and vice versa. When you're in the south, looking to the north, there's going to be a westward deflection when you shoot, and eastward direction when you're shooting from north to south in the south. Okay, so we have two different deflections that are going to be that are going to come out of this depending on which direction we're shooting. So we're told that evidence of Coriolis force is snipers have to account for adjusting their shot because Coriolis force. We were told that in military artillery manuals that they're accounting for these effects at long ranges, even though there's a heavy dispute on that because we have manuals where they don't talk about that kind of stuff and say that it is what it is. But anyway, so this is a huge point of contention. So we're going to look at a real world example here of where it would have been super important to account for Coriolis force the most. As we continue on, we'll get to that example with this broad overview of the force. But then we have the Euler's force. So think about the merry-go-round scenario for a second. And let's say the merry-go-round is stationary and you're somewhere on the merry-go-round, doesn't matter where, you're just some distance away from the center as soon as the merry-go-round starts, your time is 0, right? But then the merry-go-round starts moving, so there's now a change in time. That acceleration, that initial force that you feel that moves you forward or backwards when you start and stop is dependent on the change in acceleration. So when you're at a constant rotational speed, the Euler force isn't present anymore. It's only when there's a change in the rotational velocity. So if it's slowing down or speeding up, that is when you will feel the Euler's force. If it's a constant, then you're not going to feel it. So that comes with the change in rotation. So we have the equation here, the derivative of the rotation rate with respect to time is 0. That's when you're not going to feel the Euler force, only when there's a change. So that's how these two are distinguished from centripetal and Coriolis, because Coriolis is dependent on the cross product of the rim velocity, and the centrifugal is dependent on the cross product of like how far away you are from the. All right, so a little diagram here to kind of show that out again. We have a rotating disc, a little merry-go-round, if you will. We have what represents the Coriolis force, perpendicular to the plane of motion. We have the centrifugal force, which is pulling you outwards from the center. We have the centripetal force, which is pulling you inwards. Now, it should be noted in dynamic analysis, for example, when they do like a car driving around a track and they talk about the centripetal force that's keeping the car, that's like, counterbalancing the centrifugal force as the car is, completing its circuit. They do that analysis in terms of friction, like, something being connected to another thing, right? And then like the same thing, if you're spinning a can or a ball that's attached to a string, the centripetal force is going to be tied up in the tension on that string and that physical connection. So what they've done with gravity being big G and the little g that we measure, the acceleration that we measure here on Earth when we drop something, when the Cavendish experiment was done, they take that acceleration and turn that into big G for like a causal mechanism for the gravitational potential caused by the masses to create little g and all these things. And if any of these relationships were true and how they've derived the equivalence between centripetal and gravitation for the extension of from their to extend little g into big G and then like give meaning to the cosmos, if any of that had any validity to it, the Earth would have an orbital velocity of 30 kilometers a second, and you could measure it through the fringe displacement of light, because when you split a light beam and have it complete a circuit, it will be out of phase directly proportional to the square of the velocity that it's measuring. So there's an actual physical measurement that's relatable to velocity, and they don't have a velocity that corresponds to the sun having a mass of whatever they say the mass of the sun is, that is pulling the Earth at 30 kilometers. That is not what's not what's being that's not what's measured. That's not physically manifested. And then when you get into the gravitational constant itself, it doesn't apply on the subatomic scale. They actually completely ignore it, and so there's no real use for what they've done with it mathematically, other than using it as a constant against ratios of periodicities, which is just how long it takes for something to complete a circuit in the sky, and then they show a proportionality ratio to that constant, and they're like, look, everyone, this would only work if these constants, it's just mathematical trickery, Sean Connery, if you will, a word that we learned last week. Chicanery, just some trickery, really. All right.
Is
So
that a verb or an adjective? You chicanery someone? Okay. All right.
All right. So are these forces real or are they fictitious? Because in the heliocentric paradigm, we're taught that these are pseudo forces and they're an effect dependent, and that the effects of them arise depending on which reference frame you're doing an analysis from, which is crazy because if you pick up a box and spin it, you feel it pulling you out, you feel your arms pulling you back. These are real forces that you could feel, and mathematically they're all represented by the same thing. So why is one considered more real than the other? Now, the huge distinction here between the two models, being the mainstream model where the Earth isn't an inertial frame, or it's just inertial enough to mess around, I guess. But definitively, right, to adopt the geocentric cosmology, or stationary Earth, flat Earth, these forces are going to be real. They're real forces. You consider them all real. None of them are apparent or pseudo or fictitious or anything like that. So that's the big distinction there, because part of how they part of how they support the heliocentric model is lying about the significance of the forces, and they'll be like, well, it's just an effect, it's not a real thing. And then what they'll do is, because they have people that think that it's not an actual force, they think that, like, oh, well, we can introduce these fictitious forces into non-inertial reference frames and make them equivalent to satisfy our dynamic predictions. And like, they do all these backwards things like we talked about in the previous presentation, but this is how they got there, by making it seem like this is just an effect that arises based on your reference frame in which they're real forces. How does a fictitious how does a fictitious force cause a real effect? That doesn't make any sense. Earth, inertial or non-inertial? Well, that was the big point of the presentation 2 weeks ago, where we did the dynamic analysis and showed that only with respect to a stationary, non-rotating Earth, that Earth makes the correct predictions for everything, and only in regards to measurements velocity of light in the east-west directions with respect to the north-south is there ever shown to be any motion. That is where we adopt the model of a stationary Earth with respect to a dynamic following sidereal rotation, which is what the measurements correspond. The laws of physics were derived on Earth. The laws of dynamics are only satisfied with respect to the lab frame. Everything we just covered. So on now. So now we're going to get into some examples of these forces that are said to be experienced on Earth that have to be accounted for. Otherwise, you would miss your shot. You would miss your XYZ, right? We have a world record shot that was done 3 years ago by Shepard Humphreys, who did a shot in Wyoming for 4.4 miles. The bullet was in flight for 25 seconds, and all these news articles popped up. That world record shot could only be done by accounting for Coriolis. They would all mention these Coriolis, or that this was a factor that had to be accounted for to hit this world record shot. So Jaron emailed this guy and said, hey, can you tell me more about the Coriolis situation? And he emailed Jaron back and said, hey, you know what? Actually, we didn't account for Coriolis at all, because accounting for Coriolis over accounting for other factors like the wind would be like a 500-pound person buying thin inner tubes to give them an advantage during a bicycling. Like it's not going to be something that you account for. So at 4.4 miles, that's going to be significant, especially if you're shooting perpendicular to the plane of rotation. You're going to have that deflection is going to fight you. And these are people, this Humphreys guy and his crew that helped do this shot. These are former military people, former professional shooters. These are people that they do what's called min-maxing. They're not out there to waste time. They're going to take every advantage they can do to account for every possible variable that's reasonable to account for, so that they can make their shot. Because at 4.4 miles with a 25-second time of flight, like you're subject to so many different things. The spin of the bullet could go off, just the air, wind, just so many different humidity, so many different factors will change the flight of that bullet for 25 seconds. So you're gonna want to narrow down every possible thing that you can. And
wait, so you're saying that they made this shot and all the marketing was look at this wonderful, brilliant guy accommodating for Coriolis to even make this, and then the first time he gets questioned, he was like, "No, I didn't. No idea what they're talking about. Never heard of it or whatever.
Never met her." So he
Okay.
goes, so
Okay.
it gets even crazier, because I was talking to I Can Science That about this, and he said that, well, if he didn't account for it, then that means he shot to the east, because that would be the only way that you could cancel out the effect. And he was like, that would be direct globe evidence, because, ball spin, if he shoots to the east, and it would be direct evidence against ball spin if he shot anywhere else. Because,
I'm
4.4.
guessing it was a westward bullet.
Ooh, dude. Well, we're gonna get into that. So after we got that piece of significance, I got with Jaron. He emailed Humphreys back and asked him which direction he shot in. And Humphreys must have known the significance of this, because he asked Jaron not to share the information. And the only reason I'm comfortable with sharing it is because in the picture that they took the world record in, the moon is setting, and we could look at what direction that is from the thing. So it's double confirmed. But anyway, because I wanted to see if he would lie about it. But anyway, he told Jaron not to tell anyone, and he said that he shot south to southwest, which is
Interesting. Definitely should have accommodated for said deflection, therefore its existence proving there is no said deflection. Interesting.
There is none. Yeah, so we have the time and date from 2022 when he took the shot, and it is west to southwest that he's shooting. That is direct evidence against globe rotation, because all the instances that they tell us, and they're like, oh, well, you have to account for it with artillery, with all these different things. If it was a real, like, even at shorter distances, like, I have friends that went to the shooting ranges that shot much shorter distances, and quote unquote were told that they were accounting for Earth rotation. If this guy didn't have to account for it at 4.4 miles, the effect of that rotation, that deflection, then it's not real. It's not something that has to be.
I'm confused though. Didn't they come out and say that like football games could be won by like this Earth rotating underneath one kick that just barely made it over the field goal? Or did I hallucinate that as well? Like, how do they have it both ways?
No,
that guy just can't keep his mouth shut. I swear, Neil deGrasse Tyson. Oh my god, dude, he's done more damage than good.
That's so funny, man. And then he got totally proven wrong on that.
So it doesn't rotate under a bullet, and it doesn't rotate under a football equally. Okay.
Not only does it not rotate under it, there's no force that causes a deflection from it, even if it was like moving with it. There's no force pulling it in a different direction.
All long drive golf ranges would be the exact same direction if this were true.
Oh, dude, that's another. Dude, that's another.
Dude, all
good
golf
one.
courses would face east specifically to negate the deflection on your drive.
Dude, that's a good one. But yeah, you know what though? And in addition to that, when you do the equation for Coriolis, let me see if I can pull it up real quick. Bennett Prezi. When you do the equation for it, it's actually just kinematics because the mass on both sides cancels out because you do mass of the Earth, mass as an object, and it just turns out it's just an acceleration, which you can just if there was such an effect, right? If it did such an effect did exist, because there's no mass or dynamics associated with it in terms of the mainstream paradigm. You know who can swoop it up as ether drift?
I was just thinking that.
Ether cosmologists could. 1 second, I got
Oh, only if you already have all the prerequisite beliefs and assertions or whatever.
All right.
Looking for the kinematic dynamics, mass
Yeah,
effect, and mass Kepler,
yeah.
the third law. Okay.
Yeah, let me see if I could find this Prezi real quick. We can look at the equation.
You know, you would have figured that they would have, on their way to the moon, put together some type of demonstration to where they could show mass attracting mass. You were out there near the Lagrange point between the Earth and Moon at some point on your 6 trips. Why not have a thing just go look at the bigger object and look at the smaller object? It gets attracted towards it.
Is it this one in chat? You looking for this one? No, you found it already.
Did I find it? No, that's the Kepler thing. This is dang. So unfortunate. I remember it being here.
There's so much gravy in there. Tides, amphidramic points, ether winds, etheric drag. I just want to name all the stuff you're flipping through.
Yeah, unlucky. All right. Well, sorry about that. But yeah, when you get into the equation for Coriolis to describe it, you do mass of the object, mass of Earth, and the map, since we know the algebraic shuffling, we can just cancel out the mass and it doesn't have anything to do with it. So anyway, kinematics and dynamics, remember the distinction between the two. Kinematics is predictions of future motion and measurement without regards to, is measurement and predictions of future motion without regards to forces. And dynamics is predictions of future motion accounting specifically for forces. So one in kinematics, relative motion is true. So the words, am I moving towards you and you're stationary, or am I stationary and you're moving towards me? Both of those frames are equally valid in kinematics, and in dynamics, one of those frames.
Wait, so they both make predictions?
Yeah.
So you can make a prediction with no actual thought or account for the dynamic force behind the motion of the prediction. You could just predict it based on empirical evidence of it doing that motion throughout history.
Oh yeah, empirical observation. Yeah.
Oh, right, that's what it's called. Okay. Yep. Thanks.
Yep. And then so what you could do with that is you could have a constant, and then you could show a proportionality with respect to that constant based on a periodicity.
Right. So then you could, because they can both make predictions, you can then use the same prediction as you had with just kinematics and then claim the dynamic force as the cause of the prediction, just like that. Math is tricky.
I'm so glad you covered that, because we will be going over that at the end, where we're going to do the dynamics, doing air quotes here for the boys, of a rotating firmament to produce the forces necessary to make the Earth oblate, or whatever they say, to satisfy their cosmology. Because what we're going to be looking at is from a perspective of a guy who thinks that the Earth is a globe, but it's surrounded by a celestial firmament, which is in rotation, and that creates all the, they say the Earth's measured oblate or whatever, but no one's ever measured that. It's just deviations in the stars for their model or whatever. But anyway, to capitulate to all that, he's like, well, how do I get the firmament to generate these forces to cause that? Well, guess what? Your boy goes over the math for all of that and shows that it's just kinematics, always.
Sounds Hildegardian, but we'll see, I guess.
But he can insert dynamics into it, and then it's like, okay, so now that he inserted dynamics, do you want to say that it's any less true now? Are you going to argue against the rotating firmament now? Because now you're just going to argue against dynamics.
Bennett pulled a Newton with that one, huh? That's interesting.
It's fantastic. All right. Okay, so let's see here. Okay, yeah. So now we're going to look at some kinematics here. We're going to look at some math to describe the trick here, or one of the tricks that's been. So what we're looking at is centrifugal versus centripetal forces in a system where they would be equivalent. So I will be centrifugal and or centripetal, and E will be centrifugal. Now, when we have so the force for those will be equal. That means the mass times acceleration for these is going to be equal. But we can cancel out the mass in these equations, and we're just left with the acceleration. So this idea of the proportionality between force and mass is just mathematic gobbledygook in the way that they've asserted it. Now he gives another example here of some chicanery, where we have a quote unquote kinematic equation which predicts the angular momentum of a rotating disk, right? So we have our bold vector v is going to be our rim velocity, is going to be equal to the bold omega, which is our angular velocity, times the cross product, the radius. And that's going to tell us how fast you're spinning at any particular point of that, right? Now, when you do the dynamic equation for that to describe the angular momentum, right? Same thing. You put a m next to this. You put your scalar next to this vector, right? So now we're putting the mass of the rotating disk in here is equal to m times the cross product of r, the radius to the center. Well, the mass cancels out on both of these sides, and it again maintains this form. Now, in physics, when you describe momentum, you use the variable p. P is equal to mv. Right? It has the mass already in it. So when they describe when we have these two equations now, v equals omega cross product of r, momentum equals m times the cross product of r. Well, we're going to cancel out the m's here, and the p equals mv. We're going to cancel the m out, and the m over here is going to cancel out, and we're just going to be left with a v on this side, and we're just going to be left with the cross product of r in the same way that we would be with this. So they actually don't. There's no difference between these two, and the mass has nothing to do with predicting the angular momentum of it.
Tricky.
Yeah, and like the crazy thing is like you would never get a physicist to argue against the dynamics of this, but but with this they would be like, yeah, no dynamics, but because this has the appearance of mass in it, because there's a little whiff, you can did you smell that, Shane? There was some mass there. I thought
about a hint of mass, but it's gone now. I thought I smelled. I don't know where it went.
So, all right. So when we get into what this gentleman puts forward, back into presentation mode here. When we get back to what this gentleman puts forward for his kinematic and dynamic equation to describe the force, the rotation of the universe producing the inertial forces that are said to be experienced on Earth, Coriolis and centrifugal, even though he's taking Coriolis at face value, right? So he's like, here's an equation that would produce it if you want it. Do you want it? I got you if you need it.
Well, wait, you're showing globe right now, Alan. That's globe right there. I'm pretty sure that's all globe. So I don't know how you can pretend to.
Ooh, so here we have a little tiny globe, little dot globe, and then this big sphere here is the celestial sphere. So if we wanted to, what we could do to conceptualize this for flat Earth is this bisecting meridian here, this fundamental plane that's going through this giant sphere. We could say that this is the flat Earth, right? And then this hemisphere rotating over top is what we're describing. So the rotation of that.
Well, then, if it's the same as a flat, non-rotating plane in the middle, which you can, I guess, visualize with a hemisphere above you, then how would you tell the difference from within it if you're on a globe or a flat Earth?
Ooh, just by watching things in the sky, you wouldn't really be able to do that just from empirical observation alone. You'd have to do some things to manipulate some variables to do that, like, show occlusion timings where objects get intersected at specific elevation angle predictions by physical
Oh, gotcha.
objects, things like that.
Interesting. Okay.
Yeah. So what he comes up with here, we have F is going to be the net gravitational force exerted by a star in rotation. So in his conception, the stars are in the firmament, and then he's going to come up with an equation to describe the centripetal and centrifugal forces that keep the stars from being, shifted, shifted up or down based on their latitude as they're rotating. So what he comes up with here is, so anyway, A is going to be our acceleration experienced by the star in its daily path. R is going to be the shortest distance from the axis of rotation to the star. So in his model here, this little dot here is the Earth. So the North Pole, just coming straight out of the Earth would be coming straight up, and then the R would be the distance to the celestial sphere. From our perspective, you would think of it like, North Pole, same situation, and then wherever the star would be. But again, it doesn't even matter. It's just equations for the sky. It doesn't actually matter, as we're going to see. So anyway, D is going to be the distance to the star, which you could get from triangulating that from the, what was it? Celestial declination to the, from the equator, I think it was. It's down here at the bottom. We'll keep reading. Anyway, distance to the star, and then velocity of the star. So we're going to be able to describe how fast it's going. Sky. Then we have M for the mass of the star, which we're going to introduce later. We have delta, which is going to be the declination, the celestial latitude of the star measured from the equator. That's right. So he's getting that. So omega is going to be the rotation rate of the firmament as it passes through the axis of rotation through the north. That's going to be the sidereal rotation. So that's just going to be time. So to start us off here, the only variables that we're going to use, because we're not going to use mass of the thing yet, and we're going to derive velocity independent. We're going to derive velocity and acceleration independent of mass. So the only variables that we're going to start with are going to be the declination of the star with respect to the equator, and the rotation rate of the firmament, which is just going to be set to sidereal time. So 23 hours, 56 minutes. So doing a little calculus over here, we're taking derivatives of taking a time derivative of the change in position of the star, essentially. So if we look at this right here, where we have the position, we look at the change in position with respect to the equator. We take a time derivative of that, and did we just derive an acceleration, or did we just derive an acceleration without using the mass of the Earth? We sure did. That's what's starting us off here. So very cool. So we're off to a good note. So remember, we're starting with no dynamics, no dynamies. All right. So now as he continues on, he's going to introduce what you would do to, instead of taking like derivatives to find the change in like linear acceleration, he just converts to radians, and now we can describe this as angular rotation. So now we can get Euler's forces, we can get Coriolis, centrifugal, centripetal now, based on the different equations, or based on what we're adding to these derivatives to get the difference of what we're starting with over time. So now we have the centrifugal terms added, the Coriolis terms, and the Euler terms. Now the Euler, as we covered earlier, only when you have that initial change. So because the sidereal time is constant, the Euler force isn't really going to be present, because you would have to change sidereal time, shorter or longer, for it to manifest. But it is in the equation. But the primary ones that we're going to be focusing on are going to be centrifugal and Coriolis and centripetal. And those are all represented in what is left over when you reduce everything down. That's what we're looking at there. And again, remember, we only started with star declination with respect to the equator and sidereal rotation, and just converting that by 2 pi into radians for sidereal time. And then now we've derived, based off of our distance and change over time, we've got the accelerations. So now we know how much force is being produced by this rotation, and we have all values for that. Now, the cool thing about this is it's just kinematics, right? Well, what he goes on to show here at the bottom is you can introduce Like this, what was it? This equation right here, the final formalism of it is 11, right? So the acceleration equals minus omega squared times r minus d omega hat sine delta over the sine of delta. That's going to give you how much, the acceleration that's going to produce your centrifugal force that's going to counterbalance that star with the centripetal force that's going to keep it from you sliding up and down the celestial sphere, as he says. And that's really, that's just kinematics, right? But what he does at the end here is he shows, if you put in mass times acceleration, and then you put mass times the angular rotation on this equation to figure out what the force would be. Well, now we've made it a dynamic equation. So now we can introduce the mass of any star we want in here. This could be any value we want, any mainstream number they say. Guys, if we get a teaspoon of a neutron star and it's 80 gazillion gazillowatts or whatever, guess what? We can 80 gazillion gazillowatts right in here for this mass, and it's going to cancel out. Doesn't matter.
Whoa, even if I derive a constant based on a torsion balance and inferring based on an angle, and then I use that to calculate density of the Earth based on a known circumference, could I use that value too and have that cancel right out?
Cancels right out, brother.
No way.
Yep, cancels right out. Remember we were going over the equations to describe angular rotation and angular momentum.
Wow.
Same exact equation. Same situation. Now, who could argue one is more dynamic than the other? So when they get into GMM over R squared, right? And they got their two M's and they're like, ooh, look at these M's. You like these M's? And you're like, is that an M I smell? Is that a dynamic cause in that equation? And then when you go to solve it out, you slice that bad boy out and you're just left with a ratio of a constant. It's like, did the first ratio or did the first M, did the big M even matter? Nope.
It's like, was there even any mass here at all? Was it ever even here? Do I have any evidence of it? Nope.
One guy claimed to get a whiff of it. That's all. Some guy at a party said he smelled it once. All right. So conclusion: we have shown that the physics of a geocentric universe perfectly accounts for what is measured with the daily rotation, whether or not the rotation of the Earth, or if it's with respect to the Earth itself, because the mass in all cases cancels out. And in the final analysis, we prove that the dynamics are not proof of anything necessarily, nor are they proof against a geocentric universe. That's from Gerardus Bow from Geocentricity, Christianity, and the Woodshed. It is a fantastic read.
What a good book, dude.
Highly recommend. He is a globe lad, but the importance of what he puts forward far outweighs, that. I'm sure if he, anyway.
The ether cosmology policy is we're automatically friends with geocentric globers. We can't force you guys to accept that, but we can encourage you heavily.
Yes.
Geocentric globers are very helpful. Very good friends.
Yes. All right. Well, if there are no questions, we will read some super chats and then we will get into the Man of Stone / Taboo Conspiracy update for shadow sets.
Well, I think some of these forces that you went over, I think we name them, but people don't really know what they're used for. You could also use these forces to prove that satellites operate in a geocentric framework, right? As Whitsitt says all the time.
Right.
After you go through ECEF and ECI, you can say that real inertial forces are allowing, say, geostatic position of satellites literally are depending on centrifugal and Coriolis and Euler, as if space moves around a stationary Earth. Now, they wouldn't be accounting for forces that exhibit, from a geocentric position if those forces weren't in fact real, right? And then why would they account for fake forces in a theoretically moving universe with, interacting, but really it's everything revolving around the Earth? Why would they get to play pretend with the math and the forces that everything revolves around the observer, unless that was actually how it works, right?
Yep.
Crazy.
Exactly. All right, so we got some super chats here, starting with Liz, the Iron Maiden. She says, love Cami to the moon and back. Shout out to Cami. Shout out to Liz. We also love Cami to the moon and back, no matter how far the distance is, right? Just because the heliocentrics thinks it's further doesn't mean they love Cami more than we do. All right. And then we have Liz the Iron Maiden again. Happy birthday yesterday, Zach. Zach, it was your birthday yesterday, sir. I did not know that. I'm gonna have to
Yeah, I don't make a deal out of it. It was a
Nope.
great day.
Too late. We're making a
gonna-
deal. We're definitely singing you happy birthday on cam at the end of the show, and Cat's gonna do your cards.
Oh, you guys are too much. Yeah, it was an awesome day. I got some stuff done.
Nice.
Got to
nice.
play with fire. Perfect day.
All right, we have Run Boston Bear, who is resubbed, says, Alan, your audio, hair, and presentation are on point. You're crushing, sir. Thank you.
Dude, does that mean your hair is as good as your presentations, or your presentations have dropped quality to match your hair? I don't know.
Ooh,
I don't know how he's reading that.
I see how you would get that burn, but have you seen my hair, brother? Right? All right. I think that clears it up. So Run Boston Bear again, $10. Oh, I'm sorry. Cami, thank you for being a longtime legend and light in the community. Much appreciated, Cami.
Yeah, she is always, if not flat Earth, I mean, she studies a lot of different things, but yeah, she's always coming up to me and like, well, if you think about it this way, or if you think about this that way, she's always on. Yeah, it's amazing, her dedication to trying to at least give people ideas on how things could work. Not so much coming up with the concrete, this is how it works, and just, there's so many things out there that we still don't know, I think. So yeah, it's a blessing getting to talk to Cami every single day. I love it.
Cami is awesome. She's going to be, I think, we're doing a thing on next week on Thursday, GLOBEBUSTERS Tech. We're going to be doing a meet and greet, and I think Cami's going to tell us about Bell's theorem and light polarization. Are you familiar with Bell's theorem, Shane?
Nope, never heard of it.
Oh, dude,
She's going to nerd out.
Dude, it's awesome. You can take a polarized filter, right? And then you can take another one, offset it by 90 degrees, and then it'll completely block out all the light behind it, right? And then you can add a third. Yeah, you add a third filter at a 45 to those two 90s. Yeah, dude, it brings the light back. And they're like, light's a particle. It definitely checks out. This is fine.
I mean, the only way that works as a particle with a probability cloud is if you treat it like a toroidal field, and the particle is like its theoretical geocentric center from which all angular motion is projected, like we just did for how they got globe Earth out of elevation angles off a flat horizontal plane, right? That's the only way that would make sense to me.
I feel like that's a roundabout way to describe a wave.
Yeah, it is, right? Well, if it's not a particle, it's a toroid. And how can a particle interfere with itself and be misconstrued as a wave from a side profile or whatever? It's like, well, no. If it was a big field with overlapping, then the fields could constructively or destructively interfere with each other or whatever, theoretically. So a particle interferes with itself. But we know that's crazy anyway. It's not a particle. It's a wave. That's why it needs wave equations to describe its motion.
Yeah, and then they just square probability function on the back of the nicely, neatly wrapped wave equation. And they're like, look, there's our cloud of distribution of where it isn't, and we'll never be able to measure it. Isn't that
Just
cool? Hey, do you like determinism? You gotta give that up. What? All right. So let's go over the new Mana Stone and Taboo videos. We'll start us off with Taboo because he's going to give us the segue into Stone's video.
The second new proof put forward, I think, from Man of Stone himself. This is excellent. Right, corresponding shadow sets.
Hello, everyone.
Oops, I have to reshare to get the audio on there. Give me one.
Infinite regress.
Yep. Stop. Start.
Yeah, Spacebusters put out a video this morning about sun times, sunrises and sunsets, and how they don't predict it very accurately on, different major websites, time and date and time. he went all around the different Antarctica bases and put it all into a big data spreadsheet.
Nice. We'll
Yeah,
check
it was
that
pretty
out.
well done.
Nice. All right, so Ben's gonna take it away here.
Everyone. Hello everyone. Today, I wanted to share some more evidence of our flat and stationary Earth. This evidence comes again from the channel Space Audits and from the BitChute channel Man of Stone, who made the original observation. A big thanks to both of them. I'll have links in the description where you can go and subscribe and show your support. As a side note, YouTube took down my last video pursuant to another false copyright strike. Fortunately, you can still watch that video on Odyssey, Rumble, and BitChute. A few years ago, I originally shared this video from the channel Shadow Reveal. I love it. Shadow Reveal is a professional architect and a friend. In that video, Shadow Reveal created a Blender simulation of both the globe and the flat Earth with respect to shadows. Notice that under the globe, how the sunlight through the window starts low right here and then rises up the wall as the sun allegedly continues to drop to a lower angle based on our perspective on the ground. This is the important issue. Notice how the sunlight on the wall at sunset rises even higher than the window itself as the sun drops lower than the window. Furthermore, the Earth bulge itself, which is this shadow line right here, soon overtakes the shadow of the pillar as the sun drops even lower than the physical Earth geometric horizon, creating an upward Earth curvature shadow. On a flat Earth, the light through the window still starts low, but in stark contrast to the globe, the light from the sun through the window would never rise higher than the window itself until the sun gradually moves farther away until the sun fades out. After Shadow Reveal's simulation video, an engineer took that rising Earth bulge shadow and created this Cinema 4D simulation that shows how the alleged Earth bulge shadow would continue to rise until the shadow of the Earth itself would hit the underside of the clouds above us. In other words, if the globe were real, based on our perception, there would have to be an upward Earth bulge shadow that would be created by the physical globe and the sun dropping at an angle lower than your feet, as shown in this simulation. This upward shadow, which would look something like this, does not happen in reality, which should happen at both sunrise and sunset if the globe were real. This indisputably proves the globe false, as the sun never drops lower than the apparent horizon. It also indisputably proves globe geocentric claims and the big Earth model's false. I hope you understand that. But let's get back to the main point for this video. Fortunately, Man of Stone has a window on his house that is set up very similar to the Shadow Reveal simulation. To his credit, Man of Stone decided to test the simulation, and he has done it a couple of times now. For this recent test, he placed a magnet here to mark the bottom of the window directly across from the wall. Remember, based on our simulation, and just common sense, if the globe were real, then the light through the window on the wall would have to rise higher than the window itself, as the sun drops at an angle lower than the window. If the Earth is flat, which it is, then the light through the window would not climb higher than the actual window. Here is Man of Stone's test. I have sped up the video for brevity. According to the observation, the light from the sun never reached the height of the window. In actuality, the light from the window on the wall ended up at about 12 centimeters below the height of the actual window. This confirms a flat Earth. It's also interesting as to the difference in the amount of light going through the window. This was at the beginning of the test, and this was at the end of the test. This matches the argument that the sun seemingly fades out due to the opacity of air. This drone footage from DITRH's channel shows us how the sun doesn't actually fall below the horizon, but simply fades out. But the sun, whatever it is and however it works, always remains higher than the ground itself.
First time I saw that.
Here's a video from SpaceX that seems to show the same departing sun. And this is a new sun fade out from an airplane.
Did it fade out in space? Is that what the SpaceX showed? The sun faded out too, just to a little point. Holy cow!
Dude, it's
I
so
didn't realize
good.
that the first time.
It's
It
so
showed
good.
a SpaceX fade out where it just regresses to a point instead of receding over the edge of that ball. Like what? Why is it doing that, SpaceX?
Just always above the horizon, bro. Oh, but look at this curve. Yeah, is that optical or is that ball?
Focusing on the curve and forgot what the sun should look like on a ball getting eclipsed by its own geometric horizon.
Right?
Dude.
Dude, look at that.
That's not what it's supposed to look like, guys.
No. Dude, that's crazy, bro.
That's great. All right, continue. Sorry.
No, that's I'm glad you pointed that out because that is so significant. Remember the when we were arguing this a couple of weeks ago, we had the weather balloon footage and it was like kind of blurry, it wasn't very good, and they were like, "Oh, but that's what we predict." Like, bro, we're on a rocket now. we're as high as you guys think we're going. And it's not doing the thing that it should be doing.
And this is a new sun fade out from an airplane.
Dude, sun fade outs were like my favorite flat earth proof coming into the community. It was my, as Zack said, dude. Blew up my brain.
Manastone has given us more geometric evidence that the sun never physically drops below a physical globe barrier horizon from our perspective as required by the globe. What's also fascinating is the fact that the upward movement of the sun's light on the wall is at a constant rate until the end, where the sun begins to slow down and level out as shown in this graph. As the sun slows down, it then fades out. This again proves that the sun's apparent motion in the sky does not match the spinning Earth globe model.
It has to be constant.
This is a simple test that anyone can perform. If you would like to know more, I suggest you watch the full discussion on the Space Audits channel. I didn't want to spend too much time on the details, but I wanted to share some more indisputable evidence of our flat Earth that builds on this discussion and sunsets and sunrises. Not long ago, I shared this video of a cloud casting a shadow at sunset. Let's watch that original video again.
Check this out. Like this cloud that the sun is hiding behind has broke through.
Oh no, it's Mount Rainier.
Looks like a spotlight. And then it carries over. All the way over to here.
Dude, an
Is that not the
anti-crepuscular
coolest
sun
thing?
shadow.
It's like I'm under a giant canopy.
As I explained,
It's like I'm inside of another globe.
That's a crazy observation. That's a Mount Rainier anti-crepuscular shadow, dude.
Oh, dude, it gets better. I love this video. And then
I've taken pictures of anti-crepuscular rays. I did a video on it. And it's so weird looking. The sky, it was banded. It was like shadow, sky, all the way around me. And then they all converged on the other side.
For what seems like no real reason that you can imagine, like when you're looking at it.
Then this triangular shadow from the cloud disproves the globe propaganda's claim that this triangular shadow from Mount Rainier is a supposed upward shadow being cast on clouds above the mountain. The globe claim is entirely wrong and, frankly, a bit childish. The triangular shape is only a matter of perspective and has nothing to do with the shape of the mountain. Only the top part of Mount Rainier is casting a shadow and is being cast on clouds below the peak. The triangular shape is simply perspective from a lower vantage point. How can I say that with certainty? Well, first, the supposed upward shadow has never been filmed from the top of a mountain, ever. Second, the triangular shadow shape cast from the cloud clearly matches the shadow from Mount Rainier, even though the physical objects are most certainly different shapes. More importantly, this anti-crepuscular type shadow is 100% impossible on a globe. Because on a globe, a shadow from a cloud at the horizon could not wrap around the curvature. It would shoot upwards towards space. From the observer's perspective, the shadow would cut off at a point above the observer's head, and certainly could not make it to the other side of the sky, approximately another 100 miles away. At a distance of roughly 200 miles from horizon to horizon, that would be a curvature drop of nearly 27,000 feet. What can they claim? That gravity makes cloud shadows wrap around the curvature too? Since that cloud shadow video, I have also filmed this phenomenon. At first glance, my video is not as awesome as the first video. It was actually a lot better until I realized I needed to film it, and it died down before I started recording. But my video makes an excellent point because notice where the sun is. This video, which was filmed August 5th, 2024 at 8:35 p.m., was taken only 4 minutes before sunset. The sun appears to be lower than the clouds. You can't even see it. Under the globe, the sun would have to be at an angle lower than the clouds, but the sun
Hugely important distinction of what it should look like if the sun were illuminating it from underneath, right? That's crazy.
The sun would have to be at an angle lower than the clouds, but we know that's not true because only the tips of the clouds are casting shadows. Only the tips of the clouds are casting the shadows, and they extend across the entire sky, which is also impossible on the globe. My laser test friend Robert, who now lives in the Philippines, just sent me these photos that were taken right before sunset. Again, the shadow extends across the entire sky, and the sun appears to be angled lower than the clouds. But it can't be, since it's right before sunset. Any way you look at it, sunrises, sunsets, and shadows prove the flat Earth. Thanks for watching.
Dude, what'd you think of
Everywhere
that?
you look at it, that's awesome.
Dude, that's one of my favorites, and it's also great evidence of curved visual space. It's very complementary to that because it's like, what's the mechanism by which a shadow bends around me 360 degrees like that, like just
It's
arcs over me? Well, do you see in a 360 degree depth of vision, but only have 180 degrees for your field of view? Perhaps.
I mean, it's hard to explain, like, because like to a globe ray, right? Because what we just saw is true. Like for a globe, you would never see an anti-crepuscular ray, but what they've done is convince everyone that what we do see as a result of living on a flat
Is a
Earth with a livable
result of
sun
the
is
globe is
actually
literally
because we
bending
live
the
on a
ray.
globe. Yeah, dude, it's such a crazy mind job that it's like, how do you tell someone, like, listen, you shouldn't see that? And then like even like the beginning video with the shadow simulation, like to simulate what it would be on a globe looks counterintuitive to people because they're like, but no, every sunrise looks like that one. Like these flat earthers are just wrong. They're just taking the globe prediction again, right? That's how that's how they start to get it. And it's like, no, we're breaking it down to you how they lied and told you that everything you see is because you live on a globe. No, this is what it would actually look like if it was a sphere, right? You'd have this perfectly illuminated geometric line and a cutoff, all the illumination, and that would be reflected upward on the clouds, right? Like those things would happen. No one's ever seen it. It's unfortunate.
Think about the inversion that they had to do. They have to say that the spatial field is Euclidean, which it is, and then they go, but also visual field's Euclidean. And the only way there's a change is if you're tilted on ball. And it's like, oh, dude, what have you done?
That's the other one. Even with like celestial coordinates, they're like, okay, so the whole world just happens to be tilted at the ecliptic at the exact degree that we say the world is tilted. And then in that way, perfectly parallel light rays that no one has ever seen that don't exist actually make perfect sense in our theoretical mathematical model. It's like, okay, that's a neat trick you guys pulled again.
And that's the reason we can't draw a straight line to a triangle. Jeez. All right, so let's head over to Man of Stone's video. I just realized due to copyright situations, I'm going to link Stone's video and we'll skim through some of it without the audio on because of copyright. Here, mute.
Yeah, we can't be playing that artist.
Let's see here. We have link in chat. All right, so check out Man of Stone's video. Definitely watch this. And also I recommend. I don't think he has the full breakdown, but he did a live presentation last night, or I'm sorry, on Friday. That I can link you guys here. So if you want the full breakdown and presentation of Stone, going over it a couple of times, here's the video for that, so you can really hammer in on the details there. As we know, Stone makes detailed, rich videos that have to be interpreted via awesome graphs. So to kind of reiterate what Taboo put forward is that, the sun has to be moving at 15 degrees per hour to create the effects that we see. And we're saying that, as it gets further away from us, it's just there'll be a time when there's a deviation from that a little bit. And Stone measures that. I'm at about 20 minutes here. You could see at sunset where it's literally stops moving and then it just fades out against the wall there. That happens at 20 minutes.
Yeah, am I wrong to assume that globularity requires that to be a constant rate no matter what, because it's caused by the uniform Earth rotation, right? In no way should it hang up or pause or stop or any of the stuff that we just saw.
In no way would it ever be able to. We have. Oh yeah. So sorry. So to start us off here, Taboo went over the different geometric predictions that both models would make, and here we have on the wall here. There's a magnet that signifies the height of the window, the bottom of it, and if the Earth is a globe and the sun is setting below the horizon, then this shadow is going to exceed the height of it before the the Earth bulge shadow just sweeps by and fades to black, right? Now, what was measured here never exceeds the height of it, and it stops here, guys. Shane, what were you just saying about uniform ball rotation?
Right, it would have to have a constant velocity and speed. It would have to go sweeping all the way through. We have to maintain constant velocity, or it's not caused by the Earth rotating, right? Unless the Earth slows down when sun sets. That would be the dynamic explanation for that, right?
Now, you could make an argument like, I honestly, without it moving up any further as it fades out, I really don't even know what global argument you could make to make this happen. So
I know the only thing
I thought I
could say
had something
its-
for a second, and then it was just like, no, it would still have to be moving up continuously, even a little bit, it's just not. It's literally breaches its maximum elevation that you're going to observe it from, that it's going to get light from, and then it's gone. And this is that. So anyway, we're going to look at something really significant here that Stone did. Where he takes so this is the deviations for the 15 degrees per hour, plotting that against the projected versus what was measured, and we see that there's a clear deviation from the expected here. But the really cool part about what was done was that when you get into here, we're looking at a little hill that is a little higher than Stone's window, that gives even some more benefit to the globe. But when we get to this diagram here, what we're looking at specifically, we have Stone's westward facing door at sunset. We have the sunlight coming in, and we have the red line is going to be our magnet, and that's going to signify the position of the sun above the horizon. We have the green line, and that's going to be the shadow that is, and the angle difference between the two. So if you take the measurement from the distance between that magnet and the bottom part of the shadow where it stopped, you take the difference from that, you get it, and you draw it out for an angle. What you'll show is that the sun set above the horizon with 70% of its angular size.
This little triangle says it all. So
That's
Literally, how
so
could it set with the sun above the horizon? That also isn't possible at all for the globe. It should be zero, right? Should be zero above the horizon at sunset every time for the globe.
Yeah, it's actually, isn't it like 2 degrees below the horizon? And we're still seeing it,
Because it
supposedly?
gets refracted that little bit, yeah, to cause
Yeah,
that thing or whatever.
yeah.
yeah. So check this out. If the Earth were a globe, this red line would be under the green line, and we'd be having a whole different, you know, episode here.
This is bad.
It's devastating. So definitely check this video out. This is another huge drop where we're using triangles again to show that the objects in the sky are with respect to a flat Earth baseline, and it's never, the objects in the sky are never going below the horizon, which is absolutely mandatory if the Earth were a globe. And the celestial
Also, the crux,
phenomenon were occurring, beyond it in such a way that you're rotating away from it.
the crux of all their argument every time they start is look at the sun going beneath the. Where's the rest of the sun, flat earthers? You see this sunset? Where's the bottom half of my disk? It's obviously beneath Earth curve that you can't see, which is causing the sunset. It's like, nope. See this graph? See how 70% of the sun is above by the time it. Like, no, actually, what you're seeing is not the sun disappearing by Earth curve. It's disappearing over the horizon. How much over? Quantified, 70% over. It's 70% above. Like, come on. If it's 0.53 degrees normally, how is it setting it with a 0.34? That means most of it is there. Only the tiniest bit of the bottom is gone based on perspective. No Earth curve evident. I mean, granted, this one's like 100 meters up, I think, right? That Dearth one?
Yeah, I think so. Yeah, man, that's all I got for this week. All I got is all I got this week is a brand spanking new flat Earth proof that supplements an old argument that takes it to an extreme by drawing triangles, and no man wants to argue against a triangle. That's all we got.
Some men.
Yeah,
do.
that's a good one. That is a good one.
And kinematics for the sky, showing that the asserted dynamics are pretty much physically meaningless when it comes to cosmology, and in some cases, even on the ground, making the dynamic prediction has nothing to do with the mass. So that's pretty cool.
That's a big one.
Pretty cool. All right, so if there's any questions from anyone in the chat or on Discord, go ahead and send your request up now.
Yeah, I'm having headset issues. The plug's going out in the thing right here, and if I don't set it in the right spot, it doesn't want to charge. So I've been kind of off to the side with the thing plugged in over here.
I've lost many a headset to charging port for shenanigans, so enjoy.
That's where they make their money right there. That's the part they created to break.
Yep, the classic. You become a lifetime product member guy.
Yeah, I've been thinking about that a lot lately. Wouldn't it be nice if, instead of wasting money or wasting resources on creating inferior products, just creating the best products you can out of the materials we have, and everybody could have like the good stuff for,
then how
a
could
reasonable price. How do I make more money off
everyone's soul and profit then? I don't understand. Could you rephrase it from the world domineering tyrannical overview perspective?
I know, it's the whole I need billions to smile and get out of bed in the morning.
I need everything.
Crazy to me.
Not most of it, all of it.
Yeah. It's just I don't know. There's always going to be people like that, though. So I don't know how to combat that in any sort of way. I mean, I think it was the people making the refrigerators and stuff started it, because they made refrigerators that lasted like 25, 30 years. And they're like, we're going to,
well, guys, we're going to have that. We're going to go out of business. Here's what we're going to do.
Business.
We're going to call it planned obsolescence. We're going to make products shittier, but we're going to call it, say, better. We're going to make them better. We're going to sell it to people. We're going to make them last 5 years. We're going to sell 5 times as many fridges. Like, that's the basic business model that they have the phone now, right? So every 1 year you need a phone or whatever.
Yeah, if you want a good joke, look into the printer industry. That's such a good joke, dude. They'll literally give you a software update to brick your printer, so you have to buy a new one. Such a good prank. Or they'll just perpetually tell you that you're out of ink. Oh, Liliana's up here. Let's get Lily up here.
Like, what if you sold virus software? Would you want to give people viruses or more or less? Whatever.
Oh yeah, shout out to McAfee. That's what he did too, didn't he?
Right?
Did he prank everyone and then sell them the solution?
I think Bill Gates too did something similar.
Classic.
Yeah, well, it's nice when you're making the bioweapon and then the cure.
Right, you got to see that meme. Like, oh, I remember when Bill Gates was doing this virus software. Wonder what he's up to now. No comment or whatever.
Just helping the lads and ladettes. All right, let's see. We got Lily trying to come up, and I don't see any questions or anything like that.
No, a lot of talk about you guys heading over to the tinfoil sombrero later on tonight. That'll be a good one.
Yeah, we're getting our sombrero on.
It's a fun crew over there. You guys are going to have fun. I see you guys getting along. They're very talkative. Very talkative. You're not going to have to put on any kind of presentations or anything like that. It's just,
what?
Yeah.
That's so weird. Everyone needs presentations all the time from us or whatever.
Yeah, I'm sure it's going to be a laid back. Well, I don't know about laid back, but it'll be a conversation. They're high energy over there, we'll say. They have a lot of energy on there. So yeah, it's a fun time.
It'll be fun. That's
all right,
7 o'clock tonight.
Yeah, I think we're gonna wrap up here then.
Oh, hey.
Oh, Lily.
Hey, hi.
Made it.
Yeah. Hey, that was a great presentation, and I think that it's so great that we have so many high quality proofs in terms of physics that debunk the whole globe theory. So thank you guys for, working so hard to get all this very real physics proofs for us lay people to understand. And just wanted to give a quick shout out to all you guys, and then also remind the audience to please support Alan and Shane on their Ko-Fi accounts, and also Stone. They all have Ko-Fi accounts, so folks, sign up for their monthly subscription. That's the best way to support them, and all this great content takes up so much time. So appreciative of you guys doing all this for us. Thank you so much.
Thank you, Liliana.
Thank you so much, Liliana. And that is why you are the ambassadress of Flat Earth.
Maybe even a marketing head, I think, coming soon, a promotion or something.
Let's not get carried away. She's still under contract as the Brushtail Babe. She has a non-compete with Toby. We can't promote her yet.
Oh, that's hilarious. Yeah, Brushtail Babe is the name that the doctors have given me. I'm so honored.
That's your title.
Oh, dude, we gotta. Okay, yeah. All right. Well, we're gonna wrap up here. Everyone have a good Sunday. See you guys on the next one, episode 11, where Zack is going to be going over gravity and incoherent dielectric acceleration, if I remember. Is that it?
Well, I was going to do that, but I mean, we beat that to death. If you guys want, we could watch that one video I put together. But
some new
what
stuff.
I really wanted to show you guys was the heartbeat of Earth, the electric field actually in, live in action, and how we can manipulate it and how you can't hide from it. Like, we're going to throw it in a Faraday cage, and you're going to see that the outside world still affects what happens inside that Faraday cage. You may be blocking certain types of radio waves or EMF waves, but there is no blocking the electric field. It is
That is so
It's like,
awesome. I can't
yeah.
wait for that. That is way better than what I imagined. I can't wait.
I
Yeah, I
definitely
was
want to
thinking
watch.
about it, and I was gonna go through putting together the downward
Dude.
vector. I was like, man, I only got like 800 views on this one live stream I did, but I've never done a real video on a Faraday cage blocking out the electric field. And yeah, I want more people to see that.
You should
Nice,
definitely do
dude.
that. 'cause
And just a
that's
heartbeat.
Pivotal
of
to
Earth.
our argument.
That's their
Yes.
go-to all the time. They're like, "Look, if I put it in a Faraday, then I should float, right?"
No,
It's
wait,
like, no,
Zach,
that's
Zach,
silly.
hold on, wait.
That's
If I
silly.
put it in
No,
this
no.
magic box, that eliminates all. Like, dude, what? Yeah, that's
Yeah.
awesome, man. That sounds great. So tune in
But,
Sunday for that at 3 p.m. Eastern.
That video is pivotal to my own understanding and backing of the downward vector and how it applies and how electrostatics works. So you could.
Yeah.
I would love it personally. Is all I'm saying.
All right, so Zach,
All right,
what do you
I'll
got
mix
coming
in
up the
both
rest
a
of the
little
week,
bit.
bro?
Same old Monday, Wednesday, Friday over at Ironworks on Iron Rail Media. I think it's YouTube, Rumble. There's a few places. And then Thursday we'll be doing GLOBEBUSTERS Tech. I'm not sure what it's going to be on exactly, but we'll get together tonight and hash that out. But yeah, GLOBEBUSTERS Tech Thursday. And then, I don't know, we haven't been doing the Have No Spears on Friday nights. Walter's been feeling under the weather. He's one of my IRM buddies. He's just going through some health stuff. So if you guys have any extra, love to send or prayers, anything like that, Walt's down in Louisiana. Just send it that way. He could use some right now.
Nice, and shout out to Walt. Hope he gets better soon. Shane, what do you got coming up this week, my man? Any chance you have a entirely freshly built presentation that I have not heard of ready for Tuesday? Is that a thing, or am I just grasping at straws?
No, but I might have one for the following Tuesday because I'm doing some reading on the chronometer, meaning using things in the sky to date, like say the historical record, comparing historical records, and I need to put something together for the eclipse cycle and that. So that'll be coming soon. But a lot of reading, a lot of PDFs I'm going through still. So
very cool.
Hopefully soon.
Nice. All right. Well, Tuesday, I think we'll be doing a Battle of the Beams update. There was recently a refutation that was put forward by the YouTube channel Drunkingly Debunk or Drunk Debunk, something like that. If you search Battle of the Beams Drunk Debunk, I'm sure you'll find it. So check that out. And then, in the meantime, and then on Tuesday, we'll be going over a refutation of their biggest points, if there were any at all.
Nice. Look forward to that one.
All right. And then, of course, after that will be Wednesday. That'll be TikTok raid night, where we'll be celestial theodoliting / windowing people on TikTok. And then, what's Thursday? Thursday will be Man of Stone's going to be doing a presentation on Clubhouse, breaking down the shadow set measurements of his window and the magnet and all that. So if you want to get a fresh copy of that, or if you want to join Clubhouse and ask Man of Stone questions directly, download the Clubhouse app and type hashtag Flat Earth Gang. Shout out to the Flat Earth Gang out on Clubhouse. They're out there holding it down. That is the home base that you can go to get acquainted with the lads and ladettes over there. And then Friday, of course, will be a community Twitter night. So we'll be doing a community Twitter space for a little bit. So stay tuned for that. Hopefully Flat Earth Fridays comes back. See you guys next week. Later, everyone.